So now let's look at an example involving a function of 3 variables. So let's look at find the minimum value of x, y, z equals 2x squared plus y squared plus 3z squared, subject to the constraint 2x minus 3y minus 4z equals 49. So remember that this right here, this last equation, this is your constraint equation. So that's our g function, 2x minus 3y minus 4z equals a constant, and that constant is 49. Now we're going to find our gradients of our two functions. So look at our function f here. Find the gradient. So it'll be the partial derivative with respect to x, 4xi. The derivative with respect to y will be 2yj. The derivative with respect to z, 6zk. And then we're going to take lambda times the gradient of g. So the derivative with respect to x would be 2. So it would be 2 lambda I. The derivative with respect to y minus 3 lambda j. The derivative with respect to z minus 4z, or 4 lambda k. Okay, and then we set their corresponding parts the same, so equal 4x equals 2 lambda, the I components, the j, 2y equals minus 3 lambda, and then the k components equals 6z equals negative 4 lambda. And our final equation in our system of equations is our constraint equation, which was 2x minus 3y minus 4z equals 49. So here is my system of equations that I need to solve. So what I'm going to do is I'm going to take my first equation and I'm going to solve for I'm going to solve for x. X equals lambda over 2. So that's an x, and this part's a lambda, yep. And take your second equation and solve for y. Y will be negative 3/2 lambda. Take your third equation and solve for z. Z will be negative 2/3 lambda. And what you're going to do is you're going to take all three of these and you're going to plug them into your fourth equation. And that'll get you an equation with just one variable in it, just lambda in it. So 2, you're going to take your 2x minus 3y minus 4z equals 49 and plug in lambda over 2 minus 3 minus 4 negative 2/3 lambda equals 49. So here I'm going to get lambda plus 9/2 lambda plus 8/3 lambda equals 49. Get a common denominator of 6 here. And when you do that, you're going to get 49 over 6 lambda equals 49. So then solving for lambda, you're going to get that lambda is 6. Once you know what lambda is, you can plug this back into your equations that were up here. You can go back up to here and solve for x, y, and z once you know lambda. So if you plug in for lambda is 6, this tells us that x will be 3, y will be -9, and z will be -4. So I'm only getting one solution to this system of equations. So I learned that the optimum value is, plug it into your function, 3, -9, 4, 2x squared plus y squared plus 3z squared. So you get 147. And so this value, 147, will be your minimum value.